Okay, in this video we're going to take a look at the beginning of basic differentiation. Okay, so differentiation is our ability to find the gradient of a tangent to a curve at any point in time. Okay, so in order to find the differential, all we do is we make sure that we follow these three steps here. First of all, we make sure that our expression is written in the form of y equals ax to the power n. That means our x is not part of any fractions, it's not part of any roots, it's not part of any brackets. Okay, it's free of all of those things. We bring the power down, we multiply by that power, but then we decrease the power by 1. Okay, it's a lot easier to understand when you're just going through the examples then. Okay. So let's take a look at example 1 in this video. So I want to differentiate the following expressions. So I've got f of x is equal to x squared. Now, whenever we have our differential in this form, or a function in this form, the notation for differentiating is to say f dashed x. So I bring the power down, I multiply by that power, and then drop the power by 1. So that's going to be 2x to the power 1, which is just the same as saying 2x. Okay. Part B, we have f of x is equal to 6x to the power 10. So to find f dashed x, do the same thing. Bring the 10 down, multiply by it. So 6 times 10 is 60. 60x to the power of 10 take away 1 gives us 9. Part C, h of p is equal to 3p to the minus 5. So the notation will be h dashed p is equal to minus 15p to the power of minus 6. Okay. Remember, we're always dropping the power by 1. The next notation, so this is of the form y equals. So if it's going to be y equals, then the notation for that is going to be dy by dx. So I'll say that dy by dx is going to be minus 12 times minus 3 gives me positive 36 x to the minus 4. This next one, it says k is equal to 4. Now, in the other examples, we've had 2 letters here. This one doesn't. Technically, yeah, we do. Okay. What I could say is this is the same as saying k is equal to 4x to the power of 0. You'll remember from your National 5 index laws that anything to the power of 0 is 1. Okay? So 4 times x to the power of 0 is just the same as saying 4 times 1, which is 4. So I can go ahead and differentiate that. So I can just say dk by dx, bring the 0 down, multiply it by the 4, then drop the power by 1, but it all just becomes 0. Okay? Now, you don't have to go through that process every single time you differentiate a function when it's just a number. Numbers always automatically go to 0. So just remember that. And example F, I have y is equal to 7t. So this is 7t to the power 1. So I'll say dy by dt is going to be 7 times 1, which is 7, t to the power of 0. And again, like we said in the previous example, t to the power of 0 is just 1. So that's just 7 times 1, which is just 7. So there's 2 things to note here. Whenever you differentiate just a number, that always goes to 0. Whenever you differentiate a function that has just a single powered variable, like this one, 7t, but it's 7t to the power 1, it's just like the t falls off and you're just left with the number. Okay?